So now we're going to talk about electrical circuits and particularly direct current circuits. And now we're ready to, unpack a little bit more of how this is used practically. Some components that are important to know. We've already drawn these out. Cells, this is the positive terminal, the longer side. The negative terminal is the shorter side. And batteries are more than one cell in series, right? So positive side, negative side, and they're back to back there. If a typical AA cell has an EMF of 1.5 volts, how much EMF do four AA cells provide? And so go ahead and draw the cells and the electrical diagram, and also draw the or calculate how much voltage that would be. So go ahead and pause the clip and do that, and when you're ready to check, you can hit play to continue. Okay, so 6 volts total. These are all in series back to back, so we have 4 cells. So 4 positive and negative terminals all lined up there, and this would be the resultant positive terminal and the negative terminal there. Some other ways that we can, or other things that we're going to need, light bulbs. I typically just do a circle within a circle, and it looks pretty close to that. I think the IB equation, or IB notation, will have an X in them there. For wire, it's pretty easy, just lines, and then switches are open wires, and so that should make sense there. Voltmeters, a circle with a V. Ohm meters, a circle with an ohm symbol inside, omega, and then an ammeter with an A inside. So go ahead and draw a loop circuit that contains a cell, light bulb, and a switch, and name the components. So it doesn't matter the order, it doesn't matter the shape, as long as you got it in a loop around. It starts and finishes at one point. You can do that. So go ahead and pause the clip and do that, and when you're ready to check, you can hit play to continue. All right, so we have our cell, and we have our light bulb and our switch, and it could have been any sort of shape or whatever, as long as it'll come back there together. All right, so now put a voltmeter in the circuit, so it reads the potential difference across the light bulb. And what this would look like would be something like this. We take a voltmeter and place one wire on one side, the other wire on the other side, and we can get the voltage. And we'll look at how voltmeters work. You don't want any influence really with the voltmeter, and so the voltmeter is going to have an extremely high resistance so as to not affect the circuit. Okay, so light bulb circuits, we're going to set this up in FET. And so if you missed the lesson today, it's going to be important for you to pull this up and work through this, on your computer. You're going to go to, you can Google search FET circuit construction kit DC only, and pull that up and load that up, and you can do this along with us here. In a series circuit, all the components are lined up, so the current must go through each one. And if we have 3 bulbs in a series like this, they'll all have the same current. The current has to pass through all 3. And if you set that up in the simulation, you'd see that. All right, so what I want you to do in the simulator is make a circuit of 4 ohms, 8 ohms, 11 ohms with a 6-volt cell, and it's it may take a little bit of practice to get it set up in there, but you can put the battery in there, put the wires in there, and put 3 light bulbs in there. If you right click on the cell, if you right click on the light bulbs, they'll be able to give you the mounts, and you can adjust those. And that's what we're going to look at here. What's the current flowing through the circuit? And what I'm going to have you do is go ahead and build that first. Watch the current go through. And then let's go ahead and mathematically work through that. So go ahead and pause the clip. Go ahead and build that circuit. And then and it's going to look like something like this. You'll have your 6-volt cell, and then you'll have your 3 batteries lined up. I mean, your 3 light bulbs lined up, and you'll get that. So yeah, go ahead and pause the clip and make that. And then once you're ready to work through this, we'll do this together here. All right, so we have the 6-volt battery and these 3 in series. The way that we add up resistors in series, if we had one resistor instead of all 3, this is how we would do it. And if you want to put down this equation, it's Req, the equivalent resistance is resistance 1 plus resistance 2 plus resistance 3, and so on. So we add up the resistances to get our total amount. And so if we had one light bulb instead of 3, this is what we would have, and we would have a 23 ohm light bulb if we had one instead of those 3. So with that, what we're going to be able to do is figure out how much current's actually going through the circuit. We have a 6-volt cell, 23 ohm resistor, and so the current passing through the circuit is 0.261 amps, and that should be what you see in your simulator there. I forgot to mention that if you actually open up the junction, you can right-click or left-click rather there, and then there's a place where it says ammeter, a box where it has ammeter, so you check that, and then you can place an ammeter in there, and it should say 0.261 amps in there. And so again, you know, the important equation that you're going to need if you have resistors, and this is in series, so adding resistors in series, it's our equivalent resistance, resistance 1 plus resistance 2 plus resistance 3, and so on. Current's got to go through the same in all 3. In a series connection, again, we can use this illustration if you want to draw this out. We like to use the image of a voltage river. Basically what happens is, you know, we have a full voltage coming into that first resistor, and that first resistor or light bulb uses up some of that voltage. And what will happen is the voltage will drop at that point and be lowered. We get to the second resistor, some more of that voltage is used up, and then we get to that third resistor, some more of that voltage is used up, so that you know, at the end, you know, there's not much voltage left. And again, by the end, it would be all used up. Now, the wire itself has a certain amount of resistance, right? We've looked at that, you know, the shape of the wire, the length of the wire. So some of that voltage is used up, some of that river is used up along the way with that, but very small amount compared to the actual components, the resistors and the light bulbs that we'd have in our circuit. All right, so for this one, what I'm going to have you do is work through this first, the math of this, and then you can build a circuit on the website and give it a try. So yeah, let's go ahead and draw this out. Again, we have our 6 volts, 4 ohm resistor, 8 ohm resistor, 11 ohm resistor, and we brought them together. We have the equivalent resistance, and then we have 0.26 amp. Now what we want to find is the voltage use, the voltage drop in each. So when we reconstruct, the way that we do that is we go back one picture. So, you know, we went from here to here, and then we go back one picture, and we want to draw that down here. It's kind of a checklist. The way this works is you just go one picture back at a time. So what we want to find out is, you know, how much voltage does this use? So we use Ohm's law again. What do we know is true in all 3 of these? The current stays the same, right? The current passing through this stays the same in series. That has to push through all 3. So, you know, we have the current, which is 0.26 amps. We know the resistance of the first one there is 4 ohms. So we can figure out how much, you know, voltage it uses. So the first one uses 1.04 volts. And if we imagine the voltage river, right, it's using up voltage along the way. The second one is using V equals IR. And again, for this, I'll just show real quick. We know the current is 0.26 and the resistance is 8 ohms. And so it's going to use 2.08 volts. And then the last one is going to use 2.86 volts. And if you add them all up, the 1.04 plus the 2.08 plus the 2.86, it'll add up to be 6 volts. It's going to use the whole voltage river.